go and take your homework out and then turn your textbooks to page 224. I reckon you got some extra homework from me. You can check that first. Alright, that's last night's homework, and then previous homework you were making up. Good, thanks, sir. Word problems, excellent. Sorry, your 5 there on 25 threw me off. It was a very strange looking 5. I've never seen anything quite like it before. So it caused me to do a double take. All right, we're going to start on page 224 with the word problem. So books open to page 224. Appreciate those who had already opened their books to page 224 as instructed the first time. Thank you much. But Brecken, if you'll go ahead and read problem 15. There we go, Noah. Problem number 15 for us.
Find 3 consecutive numbers such that the first number is equal to 9 less than the sum of the other 2.
All right, so we've got consecutive numbers, and we've worked a number of word problems by now like this. And so we should know that if we had consecutive odd numbers class, my first number would be? No, consecutive odd numbers. My first number would be 2x plus 1, then 2x plus 3, then, and so on and so forth, right? If it had said even numbers, my first number would be 2x, followed by 2x plus 2, followed by 2x plus 4, and so on and so forth. But it didn't say even or odd, it just said consecutive numbers. So in that case, Brecken, my first number should just be x. And then my next number should be
X plus 1.
right, because consecutive numbers are only one apart. And then, of course, the third number.
X plus 2.
If there had been more than 3 numbers, I would have continued representing x plus 3, x plus 4, x plus 5. But it's only said there were 3 consecutive numbers. And it says such that the first number is equal to 9 less than the sum of the other 2. So let's just go through and algebraically represent all of this, Brecken. It says the first number. So what should I write down? X. Then it says is equal to.
Equals
9 less than.
9.
Help them, class. 9 less than. No, 9 less than. How do I write that? Something minus 9, right? Negative 9, as Maggie said. Something minus 9. Then it said the sum of the other 2. Now, Brecken, it already referenced the first number, so the other 2 must be referring to the second and third. So it said the sum of the other 2.
X plus 1 plus x plus 2.
What is x plus 1 plus x plus 2?
X plus 3. I don't know. 2x plus 3.
There we go, 2x plus 3. So that the first number is 9 less than the sum of the other 2. And at this point, to solve the equation, we just combine some like terms here. Brecken.
6.
Negative 6, keep the sign of the greater to get x is equal to 2x, negative 6. At this point, we need to get rid of one of the x's. Which one do I move?
Small x.
Which is
The x by itself.
the plain old x. And that moves over as a negative x. But if I'm moving the x to the right, let's go ahead and also in the same step move the 6 over as a positive. So the only thing left over here now is going to be the positive 6. And over here, we combine to get 2x negative 1x. You have 2 x's. You take away one of the x's. What do you have left? 1x. There we go. Or we could just say x. And so there's our answer. Well, part of our answer says x equals 6. That helps me to get my answers because the question was, what are those 3 numbers? Brecken, if x is 6, what are my 3 consecutive integers?
6, 7,
So I'm going to think this 8. Good. What comes after 7? There we go. Oh, I did that with my 4-year-old yesterday. You're reading a story in which there were different numbers, just gradually getting there. And then there are? No, son, there were just 5. What comes after that? 6. There we go. Stay focused. All right, questions. How many got that for number 15? How's that for 15? Nobody. Okay, it's a little pathetic. Does it make sense now? You literally represent exactly what it says. Let's take a look at number 16. And Gavin, go ahead and read that one for us, sir.
If the first and third of the three consecutive even integers are added, the result is 22 less than 3 times the second integer. Find the integer.
All right, so this time there's consecutive even integers, and once again, there are only 3. So we've got a first, a second, and a third. And how do we represent them, Gavin?
2x, 2x plus 2, and 2x plus 4.
All right, now it says if the first and third are added. How would I show the first and third being added?
2x plus 2x plus 2.
First and third, Gavin.
No. 2x plus 2x plus 4.
Right, 2x plus 2x plus 4. And we can do that in our head because we're lazy. We don't want to write that down.
4x plus 4.
4x plus 4, right? If we add the first and the third, that's 4x plus 4. And it says the result is. No, the result is.
Equals.
There we go, equal sign. We just take it one step at a time, really easy, okay? Because we like math to be easy because we're lazy. 22 less than. Minus 22, or negative 22. 3 times the second integer. Well, that's the second integer. What would be 3 times that integer?
6x plus 6.
There we go, 6x plus 6. And you just methodically represent exactly what it says. At this point, we do have a little bit of combining that we need to do, Gavin. Saw your name on that honor roll list and your brain shut off. I see what happened. Now I'll help him. Negative 16, there we go. Revoking your name on the honor roll list. Oh, it's okay. It's early in the morning yet. That's what it is here. All right, so at this point, back to Gavin for some redemption, which he desperately needs. I've got an X on both sides. Which one do I move?
4x.
Move it over, it becomes a,
2x.
well, it becomes a negative 4x, which gives us 2x, right? But we also, while we're moving the x to the right, let's move whatever isn't x to the left, which means we need to also move the negative 16, and it becomes a, which gives me 20. And we can very easily get x is equal to, but if we were really lazy, we'd say, but I don't want to do that, because I wanted 2x anyway for my first integer, so why waste time dividing by 2? If 2x is 20, and the first integer is 2x, then my first integer is 20. And my next number? And the next number? 24. And there are my 3 consecutive even integers. How many have these answers? For the second one. Okay, so Noah got one of them. Good, good, okay. Questions from the rest of us. Does it make sense now how to set these up? If it didn't before, okay, whatever. I gave you a hard time about it, but does it make sense now at least? All right. Go and turn over to page 209. Page 209. So earlier this morning, a 7th grader was coming. She's like, I really like 7th grade math, but I'm scared about next year because I'm afraid you'll beat me with a ruler if I don't understand something. I was like, I don't beat students with rulers. And I'm like, actually, that's a really good idea. I'm kidding, I'm kidding. He's about to cry back there. I'm kidding. All right, let's take a look at number 19 from the homework. And of course, we're going to set this up with a division house. We got our x squared, negative 11x, positive 30, already descending order, because they're really nice like that. And x negative 10 as our divisor. And we make sure everything's in descending order first, and it is. Then our next step, or really our first step here, Noah, is to, and when I divide the first by the first, I just get x. It's pretty easy. What do I do next, Maddie? I multiply by the whole divisor to get. All right, and then Brecken. Good, don't forget to add the inverse. Then we can actually cancel. Again, the trap you'll fall into is you're like, let me go ahead and cancel those. Not yet, you have to actually cancel. Positive and negative cancel. And then here we'll get negative x, or we could write negative 1x if we wanted to. Don't really have to. And we'll follow that up, Gavin, by Right, not
Oh,
quite
yeah,
yet.
bring down.
Bring down the 30, and then we will,
Right, first.
and when I divide the first by the first, I get, good, a negative 1. Sign, number, letters, the x is canceling, right? And once I've written that down, Noah, we just did that. We just divided the first by the first. That's where we got the negative 1. We multiply what we just wrote down by the whole divisor to get negative 1 times x, negative 1x, or just negative x. Negative 1 times negative 10, positive 10. Remember, if the signs are the same, you get a positive. And then we need to, Maddie, and when we do, and there's nothing left to bring down, which means the problem's done, and we have a remainder. Brecken, how do we write the remainder?
Plus 20 over x minus 10.
Good. And there's our answer. How many have this answer? For number 19. All right, a couple of you. Okay, questions from those who did not. All right, let's take a look at number 21. And we've got an x cubed negative 1 divided by an x minus 1. It looks like such a short, sweet, simple little problem, but there's a problem with this short, sweet, simple little problem. We're missing something. What's missing here, Gavin?
X to the second and the x to the first.
Right, the square of x and the first power of x are both missing. How do we remedy that?
X cubed positive 0x squared positive x 0x negative 1.
Good, we're going to fill in those missing powers. How many did that on this problem? How many forgot the missing powers? All right, so let me come to Noah and Brecken, and you guys will help me with this one. Let's start with Brecken this time. What do we do first?
Divide the first by the first.
To get?
X squared.
Good, because when we divide like bases, we subtract those exponents. Then, Noah? There we go, okay. And then?
You add the inverse. Cancel out x to the 4.
Ooh. You're just adding this no x squared plus 1x squared gives you 1x squared. That's why I almost would have rather had the 1 in here, just so we could see the 1 there. And then, of course, we do need to bring down the 0x, Noah, then? And when we do? Divided by x. There we go, positive x, right? Subtracting the exponents. X squared divided by an x to the first. If you needed to, again, if for some reason you're just like, I don't know why my brain's not seeing it, write it like this. Sign, positive, number, 1, letter, subtract the exponents to get the x to the first. Once we've done that, Brecken, we multiply.
X squared. Negative 1x.
Then Noah? And of course we'll bring down the negative 1, and we'll divide the first by the first again to get.
Cancel out.
It would, but when you cancel in division, it gives you a 1. Think of it this way. Sign, positive, number, 1, x's cancel. So remember when you cancel in division, again, technically you've got an x over an x. Well, when that happens, you're left with a 1. So we need to put that 1. Of course, when we multiply 1 by anything, we get itself, right, class? So 1 times x minus 1 is going to give me an x minus 1. And we add the inverse. Both things are going to cancel. And this should have been our answer. An x squared positive x, positive 1. Did you two get that answer on this one there? Gentlemen, does it make sense with filling in the gaps? And the hard thing, really truly, the hard thing about this is everything was 1s and 0s. And you'd think that would make life easier. But for some reason, it's harder for us to wrap our brain around 1. Well, just don't let it throw you, okay? Stay with it. Let's look at number 24 next. And No missing powers this time. The 2x cubed, negative 17x squared, positive 48x, negative 45. No missing powers, already descending. All divided by x, negative 3. Maddie, first up. Great job, Maddie. Let me cut you off there and go to Gavin. Keep it going.
If I first take it, 11x, negative 11x, and then you multiply everything by the divisor to get negative 11x squared, positive 33x.
Oops, I forgot to copy the x with 48x. All right, keep going.
And you add the inverse, positive and negative, and you get positive 15x.
Of course, these here cancel, and then we'll bring down that negative 45. Noah. Good. X is canceled, but you do still have the sign number to worry about. Let me make sure that looks like a 5 and less like an S. All right. Once we write something up here, what do we do with it? Multiply. $45, right? 3/4 of a football game, 45 minutes. All right. And once again, no remainder. How many have this answer? For number 24. Okay, so back row seems to have this down pretty well. Front area, a little bit of a struggle. Is it making more sense now that we're doing it together? All right, let's take a look at 25, and Bracken, I'll have you help me with this one. And that's why we do homework, you know, is to give you an opportunity to see how well you understand it. Maybe in class you're like, I got this, and then you try to do the homework, you're like, I ain't got this. I'd a whole lot rather you find that out on the homework than on a quiz or test, right? So not the end of the world if you struggle on the homework, as long as you learn from it. All right, so no missing powers. It doesn't end on the 0 power, but there aren't gaps. So that's not a problem. And this is descending as well, so it's set up very nicely for us. Brecken, go ahead and take it.
You divide the first by the first to get 2x cubed.
2 divided by 2?
1x cubed.
There we go.
And you multiply by the whole divisor. 2x to the 4th and 1x cubed.
And hopefully, to be fair, Bracken, if you'd written a 2 here, you'd have been 2 times 2 is 4. Wait a second, 4x to the 4th? Oh. And you would have caught it yourself, right? And that's one of the nice things about that initial, almost kind of checks yourself as you go. Keep going.
Add the inverse. 2x to the 4th will cancel out. And you will get 2x cubed. Bring down the negative 23x. Multiply the first by the first.
Multiply the first by the first.
Divide the first by
There we
the
go.
first.
Sign.
1x squared.
There we go.
Then you multiply by the whole divisor. 2x cubed. 1x squared.
And I just realized that was negative 23x squared. I think I made that mistake, not you. But again, do you notice how I was able to catch you? Because I'm like, wait, an x squared from an x? Oh, I just forgot to copy it, right? So sometimes you can catch your own mistakes as you go that way. Keep going.
Add the inverse. 2x cubed will cancel out. Negative 24x squared.
Good.
And you bring down the negative 12x. Divide the first by the first. Get 12.
Sign, number, letter.
Negative 12x.
Good. Very methodical with it. Sign, number, letter, and that way you don't make those little mistakes. Keep going.
24x squared.
Sine number?
Negative 24x squared. Negative 12x.
There we go.
Yep. All cancel out.
Well, once you add the inverse, yes, then they will cancel out. And there's our answer. How many got this answer for? Number 25. Okay, only Maddie. So Maddie, did you get all 4 of these right? Great job on that. You got 3 out of 4. All right. Questions on these? Questions on these? Turn over to page 214. We had one problem left at the end of last hour I wanted to work, or at the end of the hour yesterday that I wanted to work with you. Just ran out of time. That was number 15. Number 15, something rather unusual happens because there's a missing power in the divisor this time. Look at the dividend in the top. No missing powers, 5, 4, 3, 2, 1. No big deal there. But there at the bottom of the page in the divisor, it goes from x cubed to x to the first. Now, I will say this. It is not imperative that you fill in gaps in the divisor. You can work without filling in the gap. But you may find it better to fill in the gap in the divisor. In the dividend, you better fill it in. In the divisor, you don't have to. So we're going to go to Noah. Noah, do you want to fill in the gap, or you say no? If you're saying we can do it the other way, let's do it the other way.
Yeah.
You want to do it the other way? All right, so we're not going to fill in the gap here. I'm going to show you how to manage. This is the lazy man way, so this is actually my personal preference, though I will acknowledge it could lead to mistakes if you're not careful. But I'm lazy and would rather not take the time to write plus 0x squared. The basic process, go and get this copied down real quick. The basic process, really no different than what we normally do. There's just one little thing you have to be careful with. But for starters, we make sure it's descending. It is. And then we start by dividing the first by the first. Now, when we divide the first by the first, what do we get? X squared. And once we divide the first by the first, we write something down up there. And the reason we write it there is so we can, once we put it up there, we multiply. X to the 5th. Right, here you write about the 5, but it's an x to the 5th. And then here, multiply like bases, add the exponents. X cubed. Now notice, that can't go right here. That goes right here. Does that make sense? That's the only difficulty, if you will, in working with a gap, is you have to make sure you leave the gap. All right, so once we've multiplied, then we make this negative, make this negative. I'm going to go ahead and put in my ones right there just to help us out here in a minute. Here we cancel, and then here we go to get signs are the same, add and keep the sign, negative 2x cubed. Now we have to bring down, correct? But since we skipped this one, bring down the one that was skipped, not the next one. Does that make sense? So we got a little bit of a weirdness to this because we didn't fill in the gap. But it's still manageable, right? It should make sense. You bring down the next one. Well, this is the next one. It's the next one that didn't get used yet. And then, of course, we'll divide the first by the first. Think through sign, then number, then letter. Very methodically, Noah. Sign, positive, number, 3 divided by 1, 3. Now letters, x. There we go. And then once we've done sign, number, letter, division, now we go back to multiplication. Sign, number, letter. Sign, number, letter. X to the 4th. All right, then sign, number, letter. Good. And that's going to have to go right here, notice, underneath the other x squared. Does that make sense? Keeping things lined up. Again, that's the difficulty if you don't fill in this gap. How many of you are saying, I wish we'd filled in the gap? Okay, how many saying, I can do this without the filling in the gap? I've got it, okay. Okay, and Maddie's like, I don't know what I got. Okay, so Gavin, one of the reasons I'm showing this, it gives you that opportunity to realize, okay, you know what, I think I'll fill in the gap if I see a problem like this. Great, that means you've learned something from it. And if you're like, okay, I've learned just to be careful and I'm still lazy and don't want to fill in the gap, that's fine too. All right, so Noah, we've divided, we've multiplied, now we need to subtract or, right, so we're going to change these signs here and here. They also cancel. So since two terms canceled, remember from yesterday, if two things cancel, two things have to come down. We'll bring down the one that got skipped, and we'll bring down the next one. And then it's back to the beginning again, Noah, where once again we divide the first by the first. So again, think through sign, number, letter. Sign, number, letter. Cancel. X cubed, cancel each other. -2. Now we multiply. Sign, number, letter. X cubed. 3 is not a letter. So -2 x cubed. All right? Then sign, number, letter. X to the first. Not a 1, x to the first. So -2 x to the first. And then we need to, and when we do very conveniently, and so no remainder to have to write as a fraction, there would be our answer. Questions on this? Okay, so a little something unusual happening there. Let me give you another problem to work there at your seats. I got a 2x -3y in my divisor. Notice there are two different letters, an x and a y. Which letter is listed first in the divisor class? X. Obviously, that wasn't a trick question. X is listed first, which means in the dividend, the x must descend. Whatever the first letter is, that's the one that descends, because you're going to have two different letters going on here in the dividend. So the first thing I want you to do, in fact, the only thing I want you to do right now, is just rewrite the problem so that it descends the x. Don't worry about the y. Descend the x. It's the first letter. And Brecken, how did you rewrite your dividend?
4x cubed plus 4x squared y -21xy squared +21y cubed.
Perfect. Now you may notice that the y happens to ascend. I don't even worry about that. X comes first, descend the x. How many rewrote the problem the same way that Brecken did? Go ahead and work the problem now at your seats. times 3? No, it's 2 plus 3. 2 times 3. 6, which would have given you a 10. Which is then going to change the number you want to put there. It's 10 divided by 2. Okay, now notice, 10 divided by 2 is positive 5. X squared and x gives you x. Y and nothing here gives you y, right? The y doesn't disappear just because it wasn't there. So it may really help you to take the time, especially when there's multiple letters, and set that off to the side. The first divided by the first, so you can see the 5, the x, and the y. Little thing right here, keep the sign of the greater, which would have changed that, which would have changed that, which would have changed that. But the other issue is whatever sign this has needs to come in front of the fraction. It separates the fraction from everything else, so even with what you had, you needed that right there. Does that make sense? Otherwise good. Here, keep the sign of the greater. So it's going to change what you were about to write down. Okay, right here, everything was going really well, and then when you divided the first by the first, we ran into a little trouble. So if we write it off to the side, what's the sign? You had that right, the number? You had that right. The x's? And we're left with a y squared. There we go. That's what needs to be multiplied down there. And that's where you were running into trouble. Go and work the next one there at your seat. There we go. Right, no, you divided the first by the first, you wrote your answer. Now you're going to multiply this times that, and write it right here. And then this times that, and you'll write it next to it. You and Noah must have a telepathy thing. 21 minus 9 isn't 13, but both of you put that it's 12. Does it scare you that you think like Maddie? Yes. Does it scare you that you think like Noah? Terrifying, isn't it? Right. You multiply, sign, number, letters. Then here, sign, number, letter. There you go. And you were pretty much on the right track, but because you had the letters messed up, it was throwing you off here, and that's what led you to be stuck. Right? You weren't like way off or anything, just a tiny mistake I was correcting. And to make sure that the sign separates the fraction from the rest of the answer. And there we go. All right, we'll work the next one that's on the board. Of course, you won't want to copy this down on your paper the way it's written. Noah's like, no, of course not. The lazy man way to do that, Noah, is just draw a line through it and start over. Erasing takes too much time. And a little detail, you changed it to a negative, but you acted like it was still positive. So that's why it should have been a positive 12, because you should have different signs. All right, and then one other thing, if this had been right though, make sure you put the sign separating the fraction from the rest of the problem. Okay, go and work the next one. Again, don't write it down the way I've got it written down. copy it down correctly? Check your initial step. Did you get it copied down correctly? Getting some nods. Question, Brecken?
I was reading the wrong one. I was reading the bottom one also.
Oh, yeah, this is original, this is correct. Alright, so you got it correctly? Okay. Keep working at your seats if you're not already finished. No, it doesn't have to take a long time to do these, does it? If you're good with sign, number, letter, right? Once you've got those mastered, it can be a very quick process. In the meantime, you just sort of struggle through. Is this what you got, Maddie? Yeah, is this what you got? Good. Good, on that track, excellent. Reckon how we come.
Pretty good so far.
All right. All right. Careful on the division here. Sign is negative. Number's 5, but A and A would cancel. So no A right there. And the other way that you can think of this, Brecken, is you got the A squared descending. If you had another A, that would be weird because that would be 2 of the same level. That's another way you can kind of catch your own mistake. From there, it would finish out just fine. All right, let's go ahead and move on for sake of time. We have now gone through adding, subtracting, multiplying, dividing, different monomials, polynomials. We said with adding, of course, you only combine like terms. Subtracting is really adding the inverse. Multiplication, sign, number, letter, where when you multiply like bases, you add the exponents. We worked with division, which is still sign, number, letter. And when you divide like bases, you subtract the exponents and all stuff like that there. I want to now spend some time back on multiplication, but I want to spend some time on shortcuts, fast work, getting things over with, right? We talked through multiplying polynomials together. We said we can double distribute, but there are some polynomials that you can multiply and get it done quick. So the next thing I want you to put in your notes, special products. Special products. Multiplications that are special because you can do them very, very fast. And the first type of special product we're going to get is when we multiply 2 similar binomials. Now, we've actually done these already, but we did them with double distribution. What we're going to do today isn't vastly different, but it's 100% mental. It's doing it all in our head, which makes it very, very fast. When we multiply 2 similar binomials, you need to know this. You're going to get a trinomial. And we're going to multiply with a method that I call FOIL. Well, I'm not the only one who calls it that. Pretty much all math teachers do. But anyway, with a method we collectively in the math community call FOIL. FOIL stands for first, outer, inner, last. I want you to consider for a moment, once you've got that written down, this particular problem. We've got 2 binomials that are similar. Here's what makes them similar. The first terms are like terms to each other, x terms. The last two terms are similar to each other. They're nothings. They don't have any letters, right? So these are like terms and these are like terms. Therefore, these binomials are similar. If they were not similar, you would do in your double distribution, you get 4 different types of terms. But if they are similar to each other, as you do the double distribution, you're going to end up with some like terms in the middle. Well, we start by multiplying the first 2 terms together. That's what we would do normally if we double distributed anyway. Then we're going to get our outer terms. Well, that's the next thing we would do if we were double distributing, right? You distribute the x and you distribute the 3. So this is really a form of double distribution. But with your outers, it'll produce a negative 2x, and the inners, which would be the next thing in double distribution, produces a like term. As we work the problem, we're going to be thinking in terms of first, outer, inner, last. It sounds like there's 4 steps, and in a way there are. First, outer, inner, last. But when we write the answer, it's going to be your first, outer, inner, last. Say that with me, class. First, outer, inner, last. Again, so I can actually hear you. First, outer, inner, last. So we multiply, of course, the first together. Well, x times x is super easy, x squared. The outer and inner is all done mentally. Negative 2 times x couldn't be easier. Of course, class, that's negative 2x. You can read if you want to. Inner, positive 3x. But we're going to mentally combine negative 2x and positive 3x to get a positive 1x. That's where this came from. And then we get to our last, which are just negative 6. When you multiply, we are multiplying here. And we get our answer that way. Write this problem down in your notes if you would, please. A positive 3 times a negative 7. Right below it, I want you to draw 3 blanks. First, outer, inner, last. We won't be doing this very long, okay? But for now, as we begin working these problems, I want you to go and set up the 3 blanks with those labels underneath. First, outer, inner, last. By the end of the day tomorrow, we're not going to be doing this anymore. We're going to be able to move past that. But for starters, we multiply our firsts. What I mean by first is the first term here and the first term here. And that's pretty easy. Class, a times a squared. Then we get to our outer, inner. Here's your outer, there's your inner. When we multiply the outer, we get, class, sign, number, letter. Negative 7a. At least he answered. The rest of you, inner. Positive 3a. Negative 7a, positive 3a. Combine that in your head, class, to get negative 4a. Negative 7a, positive 3a, negative 4a is what we write down. And then our last, of course, mean the last term here with the last term here. That gives us, we're multiplying negative 21. And we're done. We did the whole thing in our head. No partial products, no shift over, no adding. All of it's done in our head. Write this one down. 2m positive 1 times 3m positive 8. Notice these are similar binomials. Just like these had a's and nothings, these have m's and nothings as far as their letters. They're similar binomials because they have like terms as their first and second terms. Down below it, set up 3 blanks. Label them F, OI, and L, which stands for, class, first, outer, inner, last. Say it again. First, outer, inner, last. When we multiply our first together, what will we get, Maddie? M times m? M squared. 6m squared. When we multiply the outers, Brecken, what do we get? 16m. When we multiply the inners, what do we get? 3m. Both of those positive, right? So a positive 16 and a positive 3 gives us positive 19m. Good. All done in our head. And then we're going to come to our last. No, when we multiply our last 2 terms together, we get positive 8. And we did the entire problem in our head. Again, initially here, it's kind of slow going for you. Believe me, it'll get much, much faster. But again, first, outer, inner, last, nothing on paper, just writing the answer, doing it entirely in our head. Write this one down. X negative 2y times 5x negative 4y. Notice these are similar binomials. We have x's, we have y's. That makes them similar. Down below, 3 blanks. Class, these 3 blanks are for our first, outer, inner, last. Gavin, when we multiply our firsts, what do we get?
Negative 4xy.
When we multiply the first,
5x squared.
5x squared. Remember, first literally means the first term in this and the first term in that. So that's your first. What about when we multiply the outers, Maddie? Good, negative 4xy. What about the inner, Maddie? Good, so we have a negative 4xy and a negative 10xy. That gives us,
Positive 14.
ooh, careful, add and keep the sign.
Negative 14.
Right, negative 14xy. And then we're going to multiply our last together, Brecken.
8y squared.
Positive 8y squared. The difference, Maddie? We're multiplying the last together. Negative times negative gives us a positive. But when you're adding the negative 4 and a negative 10, you're adding and keeping the sign. So again, a little bit of mental dexterity here, keeping straight what's going on. And there's our trinomial answer. I'm going to make this kind of easy on you as we start out. I've got a handout, and we're just going to kind of work our way through methodically here on the handout. If you're watching on YouTube, the handout, there's a link to it in the description of the video. I want you to start just on numbers 1 through 4. Now notice, on number 1, 2, 3, and 4, if you'll jot the answers on your own paper as opposed to on the handout, on 1 through 4, they've already done the firsts. They've already done the outer inners. So all you have to do are the last. So very quickly on your paper, multiply the last on 1 through 4. Just multiplying the last. Don't write anything down but the answer to the last. You're not copying the problem, the answer down. Just telling you what are the lasts. Really quick and easy. All right, number 1, what do we get, class? 12. Number 2, negative 6. And they already gave you the negative, but negative 6. Number 3, positive 6. Number 4, positive 12y squared. Do we see what we're doing now? All right, now do 5 through 10. Very quickly, same exact thing. We already did the first, we already did the outer inners, now do the last. Stay with me through the bell. We're focusing on just the last. Sign, number, letter. Maddie, number 5, what's the last?
15.
Positive 15. Number 6, what's the last, Brecken?
Negative 38 squared.
Negative 38 squared. Number 7, Gavin.
Negative 35.
Good. Number 8, Noah. Good. Number 9, Maddie. I'm sorry, number 8? Number 8 was negative 24. Isn't that what he just said? Yeah. Number 9? Negative 6y squared. And then number 10, Brecken?
Negative 6b squared.
Negative 6b squared. Numbers 11 through 16, very quickly. I want you to just do the first. Notice they already did the outer inners. They already did the last. You do the first. Number 11, Noah, what did you get for your answer? 15x squared. Number 12, Gavin.
12.
Number 12, Gavin, what did you get?
12.
A 7a times a negative 3a. You're doing the first, Gavin. They already did the last. Maddie? Negative 21a squared. Gavin, coming back to you, what should you have gotten for your first on number 13? Forget erasing. Look at number 13. What should you have gotten for your first?
Negative 6y squared.
Good, negative 6y squared. Bracket number 14.
12b squared.
Ooh,
18b.
18b squared. Number 15, back to Gavin. What should you have gotten?
Negative 4x squared.
Negative 4x squared. Number 16, Noah. Negative 10x squared. I'm going to keep you a little longer. I'll give you a pass to your next class. Number 17 through 20. They've done the first and the last. You do outer, inner. You need to understand this before you can do the homework tonight, so I'm going to keep you just a nudge longer. I'll give you a pass. 17 through 20, figure out the outer, the inner. If you need to write them down, you can, and then figure out what the sum would be of the outer and inner. What is y'all's next class, by the way? English. So you don't mind staying a little longer, right? Y'all are all, yeah, it's all together in the same class. Pencils down. Let's see how you did on the ones you got done. Number 17, 4x and 18x gives you a positive 22x. Number 18, 4xy and negative 18xy gives you negative 14xy. Number 19, negative 4x, negative 18x gives you negative 22x. Number 20, 40xy and a 9xy gives you a 49xy. And number 21, 36a, negative 18a gives you 18a. How did we do of the ones we did? Even if you didn't finish all of them. Did you get all the ones you did right? Gavin saying yes, Brecken saying yes, Maddie, yes, Noah? Missed one. Which one? The rest of you copying down your homework. 21. So you had a 36. Where's number 21? It can't be 21. Oh, okay, gotcha. So you got, oh, careful, 4 times 9 is 36, not 27. That's what happened there. And then positive 18. Oh, okay, you start looking at the last. Do you see that? You did firsts and last instead of outers and inners. So think of a little rainbow, outers and inners. That's what happened. All right. You're going to be practicing the 1 through 9 odd is the full FOIL process. We're going to do the whole thing through. And give that a try. And then once you got the copy down, you are dismissed.